So this is the first Plugable Office Hour, and we're going to use this time to kind of talk about technology and particular kind of great desk setups, and also take some questions. So first of all, I'd like to check with the live chat. Is the audio and everything coming through? Can you guys all hear well enough? Okay, I'm waiting for somebody to just kind of acknowledge whether the audio is coming through. Okay, great. Okay, so you know the we are a company, Plugable Technologies, that lives in this space of all of these things that you connect to your computer. And as laptops and phones have gotten thinner and lighter and don't have all the same ports right on them, kind of what you connect to your laptop has become a lot more important. And there's some amazing things that you can do in terms of desktop setups. And we wanted to just kind of talk through those, but at a different level, kind of a little bit deeper. Talk about some of the problems and challenges people have. So in a future episode, we're going to try to get kind of the ability for people to hop on here and ask questions on video. But for this one, we're just going to do it in chat. So I'm going to, kind of pull questions out of chat. So if anybody in the chat right now has any questions that they want to ask, we'll pick from among those and use those as topics to talk about. So yeah, today was kind of a good day to have this first Pluggable Office Hour because today the new DisplayPort Alt Mode spec was announced for USB 4. Now, what in the world is that? Uh, when with the USB-C connector which is that new USB connector that's smaller, rounder, and is reversible like the Lightning connector has been for Apple. That is this kind of amazing amalgamation of different technologies that are done through that connector. And one of the tricks that is used to achieve that is this concept of having alternate modes, which is totally different than anything that came previously with USB before. Uh, Basically, they came up with the concept of saying, well, okay, we need a number of twisted pairs, a bunch of lines, data lines within this USB-C cable. What would happen if we actually allowed the the computer on one end, the device on the other, to actually negotiate for ownership of those lines and be able to run very high bandwidth, high throughput signals over those, like video signals? Because really, prior to that, most people in the USB kind of space thought of USB as not being something that you would connect video through. Now, in fact, we had a lot of products in that area, and there's a technology out there called DisplayLink that does that in a particular way. But for a lot of people in the industry, it was like, well, we want to run graphics natively over USB. And so this concept of alternate modes came up and was designed into the USB-C spec, where one side could say, I support DisplayPort and routing that over USB-C, and DisplayPort is one of these major graphic standards. And as long as the device supports that same DisplayPort alternate mode, we can actually talk with native DisplayPort signaling and have all the features of DisplayPort, but over a USB-C cable. And that actually became one of the few alternate modes, really the alternate mode that is present in almost every USB-C device. If you've got a Windows PC or a Mac and it's got a USB-C port, it supports DisplayPort over alternate mode. Now, some phones don't, so it's not totally universal, which is one of the problems with USB-C. All these options. But So now today was announced a new version of that spec, the DisplayPort 2.0 alt mode spec. And it basically it's tied to USB 4, which is another new technology that's coming. So this is announcements of stuff that aren't present yet in any computers, but will be in next year in 2021. And one of the first questions that we had, which actually we don't know the answer to yet, is it part of that spec to require backward compatibility with the current DisplayPort alt mode spec? Because that's there's many hazards of this alternate mode strategy of kind of negotiating, saying, hey, do you do this? Do you do that? Okay, great, let's do it. Well, how does the end user, how do you and I, when we're buying a piece of equipment, know whether this side supports and that side supports the same thing? And especially now as we move into the future where we're going to have versions of these specs, and this one's on the old version and this one's on the new version, unless the new version stuff is required to support all of the old versions, it might not work. Just interesting today that we had that announcement. Some exciting new capabilities for USB-C in terms of USB, making use of USB 4 and DisplayPort 2.0, but raises a lot of compatibility issues, and we'll just have to see as that technology rolls out whether those compatibility issues kind of rear their head. Okay, great. So want to kind of switch to some of the questions that we have coming in the comments. So we have a question: if I have a 16-inch MacBook, which dock should I use if I want two displays? Okay, great. So the I said that DisplayPort over USB-C is the one alternate mode that you can count on if you've got a USB-C port on a Windows or Mac PC. One interesting thing about that spec is kind of natively, it only supports a single display. So that question of how can I get two displays? Well, unfortunately, if you're going to use that kind of baseline USB-C alternate mode, there's no way to guarantee to get two displays. Um, what it takes to get two displays, and in particular in this case on this MacBook, is to use a newer, different alternate mode called Thunderbolt 3. Now, you may not think of Thunderbolt 3 as just an alternate mode of USB-C. In fact, a lot of consumers are confused. What's the relationship between Thunderbolt 3 and USB-C? But that's actually what it is. Thunderbolt 3 is designed to be an alternate mode of USB-C. So when you have a Thunderbolt 3 capable system, like the MacBook that's being asked about, and you plug in a Thunderbolt 3 peripheral, it actually starts out just talking USB signaling and saying, oh, USB device, okay, great. And then as part of that process, it starts a negotiation where it says, what alternate modes do you support? And the device, the Thunderbolt 3 device, might be looking to see, okay, is this a laptop that supports Thunderbolt 3? And when in fact, in this case, you have a MacBook that does and reports that it supports Thunderbolt 3 alternate mode, then a Thunderbolt 3 dock or graphics adapter can then turn on that alternate mode, switch into Thunderbolt 3 mode, and now have this potential through Thunderbolt 3 technology to get to two displays. So how does Thunderbolt 3 do that when DisplayPort over USB-C can't do that? And it's interesting because they're really both doing the same thing underneath the covers. They're both negotiating to take over wires in the USB-C cable. The USB-C cable has 4 super speed pairs within it. And the DisplayPort over USB-C most commonly will use 2 of those super speed pairs and then leave the other 2 for USB data. Thunderbolt 3 uses a different strategy. It takes over all of the super speed pairs, runs a much higher 40 gigabit per second, or well, actually 220s, high speed signaling over it, and then routes USB and DisplayPort and other signals kind of over this higher speed Thunderbolt 3 protocol. So on that MacBook 2016, that's what you want to get the two displays. Is you want to buy a Thunderbolt 3 dock. So a great one to buy from us from Plugable is the TBT3 UDV. It's a award-winning Thunderbolt 3 dock that has been out for about 2 years, well proven. You can read, has lots of reviews on Amazon if you're interested in seeing what experience other people have had with that dock. Beautiful aluminum case and lots of ports on that dock. Great dock to pair with that MacBook. Now, the question was MacBook 16-inch, which I know is one of the newer MacBooks. One hazard to look out for is the very first MacBooks, the ones from 2015 and 2016 with a single USB-C port. Those MacBooks actually predated Thunderbolt 3. So if you have one of those older MacBooks, it's not newer, and it's not a MacBook Pro, because the MacBook Pros, once they introduced the USB-C port, it was always Thunderbolt 3. So if you've got a regular MacBook and it's older, you've got to check first to see if it has Thunderbolt 3 before buying that dock. Okay, great. So that was an awesome question and really kind of let us get into a lot of stuff there. So let me look back here. I don't want to miss some of these older questions. So yeah, there was the question of what's the difference between USB-C and Thunderbolt, and that's exactly it. Thunderbolt, is a signaling technology that is designed. Thunderbolt 3 is designed to run on top of USB-C. It kind of starts with a USB-C connection and then negotiates up to these advanced capabilities if both sides of the connection support that. Okay, great. So here's a question. Will my USB-C laptop charge from the pluggable 60-watt USB-C laptop charger? Will it charge faster or will it blow up my computer? Which is, hey, that's a logical thing to be worried about. Because my computer actually only came with a 45-watt adapter, a kind of a smaller, less powerful brick. So if I buy that pluggable brick that is a 60-watt capable brick, is that going to blow up my laptop? Very, very kind of common question and common concern. So the first kind of quick and easy answer is no, it won't. And then let's kind of back into why that's possible. That you could have some of these numbers maybe not match up, but it's safe. So up until USB-C, power supplies were relatively simple. You would plug in like a barrel, those round power plugs, and it was totally non-standardized. Those barrels there's no standards body for that. They have a positive and a negative kind of in the inside and outside of the barrel, and then the barrels are different sizes. And then different devices are expecting a different input voltage. And without getting into too much about electricity and current, basically there's really two big things: voltage and amperage. Voltage is is the one that you got to watch out for, because if you give a device too high of a voltage it does not expect, it can actually damage devices. And we talk about kind of voltage being just kind of present on the line. So all it takes is for um, a device that's only designed to handle 12 volts, for example, to have something that's 20 volts plugged into it, and it can damage it. And then amperage is how much of that voltage the device is pulling. And that is the way to think of it. The device actually, so in a sense, your power source chooses what voltage to make available. And then your device chooses what amperage of that voltage to pull to itself. And the combination of those two, voltage times amperage, is watts. So the question was asked in the form of watts. Okay, I bought a laptop. It has a 45-watt power brick that's USB-C. Let's stay with so now we're in the USB-C world, and now I buy a pluggable 60-watt USB-C adapter. What's going to happen? Well, here again, USB-C has done something kind of really interesting that can create that both solves problems and creates problems. There's a whole negotiation happening when you plug in two devices that support what's called USB-C power delivery, which is the standard running on top of USB-C for how devices like laptops charge. Kind of like the alternate modes we were talking about earlier, the devices advertise to each other what I can supply as a power supply and what I need or what I want as a laptop. So that laptop with 45 watts, they're going to, according to the USB-C spec, be looking for a power supply that is able to offer either 15 volts, 3 amps, which is 45 watts, or maybe 20 volts with get my math right, 2.5 amps. Did I do that math right? Something like that. Um, And then the laptop power supply is going to be doing that. They're going to be offering, okay, yes, I'm capable of 20 volts, I'm capable of 15 volts with either these specific amperages or a range of amperages. And then if the two sides line up, if the laptop and the power supply say, ah, yep, I can supply what you're needing, then they switch to that higher voltage, and now the laptop can start drawing current from it. And so, as long as both sides do that negotiation correctly, there's no danger because the laptop is in control. It can tell the power supply, what it wants in terms of a voltage, and never get more than that voltage. And then once it gets that voltage, it's choosing how much power to draw. So it's not that a 60-watt charger is pushing 60 watts at the laptop. That's not the way it works or the way to think about it. It's actually that the laptop is choosing how much power to draw. A really related question, which came up recently, was, okay, great, it won't destroy my laptop, but if I get a 60-watt charger, is it going to charge faster, and is that maybe going to hurt my laptop and reduce the lifespan of its battery? And the answer on that is the same answer, no, because the laptop is in control. And regardless of whether you have a 60-watt power supply or a 45-watt power supply, the laptop is unless it's designed to take advantage of the higher one, if it's really designed for the 45-watt power supply, it's going to draw the same amount as it would have from the 45-watt power supply, no more, no less. It's going to be exactly the same. The power supply is kind of advertising extra capability there, that the laptop is going to be able to see that it's there and then not use it because it doesn't need to, because it only needs 45 watts. So with USB-C power delivery, because it's not just some dumb plug that doesn't, that it just has to be the right thing plugged in. Rather, it's this intelligent system with clear communication and negotiation on both sides. It gives the ability to do these really, what it electrically is kind of a fancy thing of having all of these charge rates the whole way up to potentially up to 100 watts, and the whole way from 5 volts to 20 volts, and to do that in a way that is perfectly in control, by the laptop, so that it's safe, and you can use anybody's USB-C power supply, plug it into your laptop, and never need to worry about it hurting the laptop. Now you may, okay, so now let's talk about the other thing of not working, which is, okay, the laptop's never going to get hurt. But could it be that the power supply doesn't give what the laptop needs? And that answer is yes. So let's flip that question on its head. Let's just say the power supply, the USB-C power supply, is that 45-watt power supply, and now the laptop wants 60 watts. And the laptop's kind of a high performance laptop, and it's reliably going to draw more than 45 watts of power. What's going to happen in that case is the designer of the laptop might say, well, if we allow this thing to charge on these lower speed chargers, it's going to be a little bit deceptive. It will charge, or it's possible we could make it charge, but it's always going to be run this risk that we're actually drawing more power than we're getting out of the charger, and so the battery will be dropping, and even though it's plugged into the power supply, and that might create a bad user experience. So in some of those cases, the difference, how much the power supply is able to give and how much the laptop needs, is so different that the laptop will actually choose to say, well, I'm just not going to charge at all. This power supply, it's too far off. I really need 60 watts, and this is a 45-watt power supply. Not going to charge. And so as an end user, you'll just plug in this USB-C power supply that you thought maybe was the right one for your laptop, and you'll go, the charging icon isn't on. What's going on? And it may be because that USB-C power supply is a lower wattage, not nearly enough for the laptop. And then there's a middle ground where some laptop makers have kind of taken the philosophy of, well, we're always going to, use whatever power we have available for the most part. We will charge somewhat, but we want to let users know, we want to set the expectation that this isn't, we really need a bigger power supply than this. And if you're using your laptop while you're charging, it might actually drain. So let's pop up a warning. And in fact, USB-C provides this mechanism called a billboard, and also there's potentially ability for the drivers that that are controlled by your BIOS and stuff to do things too, to pop up a warning and say, well, we're going to be charging slowly. You plugged in a 45-watt power supply when we really need 60. So we're charging, but charging slowly. So there you go. So again, really interesting with USB-C, these amazing capabilities because there's so much intelligence in both sides of the devices, which helps avoid really terrible problems and make really great things possible. But it's also a little bit complicated for you, for all of us as end users to figure out, okay, what should I get? What will work? Okay, so let's see here. We have a question. Okay, somebody who's been buying pluggable products for years, and going to be buying some Thunderbolt 3 products. Um, and oh, darn, I didn't see the question. So I was, I needed ones that handle the power delivery spec. Right. Okay, great. So the question basically is, does every USB-C device and every USB hub and even older USB devices, do they all charge a laptop or charge any device? And the answer is no. So with USB-C in particular, the newer technology, power delivery is an option. A particular port that you have may or may not support drawing power with power delivery and may not support charging other devices with power delivery. Most of the laptops that are on the market support drawing power through USB power delivery, charging the laptop. But not all of them, especially some of the lower end ones. They'll have a USB-C port, but they ship with a kind of an older style barrel power supply, and that's what you got to use to charge the laptop. Correspondingly, on the device side, for example, Plugable will sell docks that will have USB-C ports on the dock. So you've plugged the dock into your laptop with USB-C, and now the dock has a whole bunch of ports on it, including some extra USB-C ports. Very often, those ports can't and won't support USB power delivery because there just isn't enough power going to that dock to then charge one or even several additional laptops in addition to the one that you're plugged upstream to. So you've actually got to be kind of aware and careful in looking at the specs for things to figure out, okay, is this port or this device capable of charging my laptop, and is my laptop capable of charging on USB-C? And then the easier question is the older technology, USB-A. USB-A was, which is that kind of square plug, the USB that we lived with for almost 20 years. That has no such capability to do these kind of higher wattage, higher voltage charging. USB-A originally was only designed, like with the USB 3 spec, to do 900 milliamps, about 1 amp, at 5 volts. So that's about 5 watts, or about 1/20th of what USB-C is capable of. That was later extended with something called the battery charging spec, which got that up to, in a standardized way, 1.5 amps. So basically, you could get to 7.5 watts. And then Apple and Samsung and a bunch of other guys did some proprietary stuff that was never standardized to get up to 2.4 amps. So basically, roughly around 12.5 watts. But again, all of that stuff on USB-A, 12.5 watts is only, whatever, 1/8 of what USB-C can do. And in most cases, except for a few really rare circumstances, it's not enough to charge a laptop. So pretty much, if you've got a USB-A port, don't even think about charging a laptop. The capability is not there, and it, in fact, won't work. Okay, great. So let's see, what else do we got here? Okay. And okay. So I'm going to take one last question for this office hour. So docking is great. So you don't have to keep plugging cables in. That's right. Okay. So we do you have a pluggable docking station? Okay, great. Does Plugable have any GAN chargers in development? Okay, that's a great question from MJ. So, okay, so what is GAN? Okay, so GaN is, and I hope I actually say it right, gallium nitride. It is a replacement for silicon. So actually, if you know anything at all about computers, I mean, really all the chips that are in our computers today, we've been using for, gosh, almost 30 years, are almost all silicon-based chips. Um, yeah, but there's an interesting thing that happens in some of these chargers, especially ones where you're plugging into the wall and you're having to convert alternating current, AC, to DC. Um, the most efficient of those designs are always designed to take a small amount of AC power and convert that into direct current, into DC, which is the that when I talk about those voltages, 12 volt, 5 volt, that's DC power. So, if you when you're doing that conversion, you need these electrical components called like capacitors and diodes and other things like that. Well, if you're doing big chunks of electricity that you're converting, those components need to be a lot bigger. Well, there's this kind of next generation, you could kind of call it, after silicon, which is these gallium nitride, which is quite a bit more expensive to work with in terms of making chips from it. But those chips are able to run at much higher speeds. And interestingly, I mean, this has had applications in certain types of high-speed chips going back a long time. But today, as we sit in 2020, the place where these new super high-speed chips are actually getting used first is in this scenario of converting power from AC to DC and then DC to DC. These chips, being able to run at a super high frequency, are able to do very small amounts of conversion with each step, and that allows all of the components to shrink. And this has caused this to become popularized, that you have these GaN chargers that are much smaller, less heat, with these kind of higher capacities for charging and handling large amounts of power as you're starting to get with USB. So it's kind of cool. It's basically by using this new type of replacement for silicon, you're able to get higher speed chips, which is able to enable you to create smaller chargers, which is really nice. So yeah, so Plugable, as anybody who's kind of working on charging devices, is either planning to or using GaN chargers. Most of ours right now, we actually don't have a lot of products that are in the kind of portable USB charging space, and those are the ones where this is the highest value, because you can now really get those down, and it's kind of worth the extra cost for those. Most of our power supplies are more the power supplies that then connect into your dock, or the power supplies that are a brick that charge your laptop. So we've not actually been on the front edge of rolling out GaN products, and there's actually none that you can buy today that are pluggable products that have GaN in. But we do believe that this technology is going to go everywhere, because basically, as we look at the math of even when you don't care so much as a user about the size of the power supply, just simply getting that weight down so that you can get the package size down and ship things less expensively, and save energy in terms of kind of shipping and environmental impact. Very often, it's worth going to GaN. So over the next few years, I believe actually that almost all power bricks and power supplies are going to end up adopting GaN technology, simply because even though it's slightly more expensive, you save the money back in other ways. Well, there you go. This has been, kind of our first episode of, this Pluggable Office Hours. Hopefully, you get the flavor of this. We really want to talk about, this technology of how USB works, and how you can have a great desk setup, and all of these kind of confusion and questions about different connector types and technologies, and will this work with that? Plugable is a brand. We connect this with that. So this is our business. This is what we do every day. Is we design products that try to solve these problems. And we have an all U.S. based customer support team right here in Redmond, Washington, that are answering all the questions. So when you email support@plugable.com, you're actually getting somebody here in the U.S. somebody who's been involved in developing these products, answering your questions. And that's really, really unusual. And the reason why we do it is because we kind of ask that you compromise with us and send us an email rather than calling. But in return, we're going to have somebody responding to your emails who's super knowledgeable about the product, knows all the kinds of things I'm talking about, and be able to untangle what's going wrong and get you back up and running easily. So thank you so much for joining us, and look for us again this week at the same time. So really appreciate it. Thanks and good night.